This artificial intelligence piece here, right? So going back to another quote, pioneer and economist Herbert Simon inaccurately predicted in 1965, machines will be capable within 20 years of doing any work a man can do. Notice he said man, right, rather than person. Similarly, in 1970, Marvin Minsky wrote, within a generation, the problem of creating artificial intelligence will substantially be solved. That did not come to pass. Right? It took another generation to get where we're at. And between that, a lot of our AI experts were thinking, well, okay, this is just never going to work. We're never going to be able to get there. There's something about the human brain that's unique. We don't understand what makes intelligence work yet, so we'll never be able to replicate this process. Now it's happened, okay? Now when we say the AGI piece here, right, going back to these predictions here, they said, well, AGI will arrive in 12 years, predicted in 2017 by futurist Ray Kurzweil. And the other is AGI will never arrive. And this was a prediction made by Gordon Moore, St. Gordon Moore, who came up with Moore's Law. Certainly seems that probably the Ray Kurzweil camp seems more realistic at this stage. We're only, 4 years away from this now, and we've seen what's happened in the last year. If you had to ask me this 2 years ago, I'd say, yeah, probably this. Now I'm leaning more towards this camp over here on this side, okay? It's going to be one or the other. Either it's going to happen or it will never happen in this case. Now, it could still take another century before we get to what we think of as real artificial, right, general intelligence. This capability to think like a human brain, to learn new things, but more importantly, for an AI to be able to figure out what it doesn't know and then figure out how to retrain itself to learn that information, okay? Could be somewhere in between. Whatever, we don't know. It's a science fiction class, right? So we can say whatever we want to in that regard. Now, to wrap this up real quick here on this side so we can get to our demonstration, let's talk a little bit about the differences that we have. One is what we think of as narrow AI versus AGI or ASI. Weak, basically, yeah, these are coming over here and like, yeah, I can play chess, right? I can drive your car, right? But I'm not going to be able to talk to you. More to a general AI. This is like, okay, yeah, we have HAL from 2001, R2-D2. Why can't R2-D2, right, just use English? Keep in mind, right, none of it's English. It's all Star Wars, right? It's a galaxy very, very far away. Right? It's a different language. It's all just translated for our benefit as part of that. But why does he speak in beeps and boops, right? You'll notice people understand him completely, right? Well, they've got that process going on that's never explained, right, in the actual movie canon, right? Oh, I can understand what R2-D2 is saying because I've got my translation algorithm going on that tells me. So you don't need to. R2-D2 can speak his native tongue, right? Whatever was taught, right, by his mom when he was growing up, okay? Now, the AGI component then is to be able to take all this information in, okay? Now we have our R2-D2, which is general, okay? But now it's going through the process of, all right, R2-D2 decided this whole, following a Jedi stuff around is not for me. I'm going to go off and, write a play, okay, about my life's work and everything that I've seen, right? So this is where we're at right now. This we've done a pretty good job at. We can design these narrow, specific tasks, which will be really beneficial to us from a productivity standpoint. Hey, I can take in medical information on a diagnosis and I can provide a pretty accurate diagnosis now, probably better than a doctor can, and I can give that information to the doctor that then they can then use it to take information. The next piece then is, okay, replacing the doctor, right? And then our artificial superintelligence is, well, AI decides whether we live or die. Okay? So what's that path look like as we move forward? So let's go back to another example, our kind of final science fiction example as part of this. So this is the flip side of Hal, right? His sibling, Sal, in this case.
Afternoon, Sal. Do you have anything for me?
No, Dr. Chandra. Do you have anything for me?
We have often spoken about Hal.
Yes, we have.
We've spoken about Hal's anomalous behavior. You have told me that we cannot solve the problem of Hal's behavior without more information.
That is correct. I enjoy talking about Hal. I agree that we need more information so that we may solve the anomalies.
And how do we get that information?
That is obvious. Someone must return to Discovery. That person should be you.
Well, I agree. And now it looks...
Okay. Now, without going through these details, notice that this was 2010, right? So a decade or so after 2001. And we have the process, which we're pretty close to right now. The ability to come into your office, you say, hey, computer, do you have anything for me? The computer says, no. Do you have anything for me? Right? It sounds, much sweeter than that in terms of her response. And then have that dialogue and interaction, okay? That Star Wars component where we're saying, hey, C-3PO, you're a protocol droid. I've got visitors coming in internationally. What should we do to prepare for this? They provide some information back and you say, that's a good idea. Let's do that. Go make those plans. Or no, why don't you do this instead? And start to have that real life interaction and process between that, okay? So let's do one final version of this plot that we have, okay? And this goes back through kind of the history of the entire class, right? When we started off, right, discussing the universe and Big Bang and formation of the solar system and the Earth and life on Earth, right? Here's our log plot again, and notice now this is a true log-log plot. And what we're doing is looking at paradigm shifts in the way that things operate with life. So we start over here at life, and really early on, this is just the process of getting more and more complicated. And since it's a log-log plot, right, this is time to the next event. So these are really, really big time jumps here that are getting more and more and more compressed on this x-axis. Simultaneously, time before the presence over here, right? So short time, long time, long time. And what do we see again? Straight line on this log-log plot. The next things are always coming faster and faster and faster. We start here with primates, humans walking upright, spoken language, art in early cities, agriculture, city-states, industrial revolution, the computer, right? Notice telephone, electricity, radio, the computer, and then the personal computer. That straight line goes down and down and down. If you keep that line going, what happens? It means that eventually changes are coming in decades, then years, then months, then days, then hours, then minutes, then seconds. Does this keep going? Do we break it? Do we hit some wall at this point where we say, okay, no, we're not going to do this anymore. We're not going to see this process. Something changes where it becomes static and it essentially levels off. Why do we think that based upon everything that we see, particularly with what we have with the capability for AI now and computers to be able to go through this process on their own, right? So this process here is essentially known as the singularity, okay, in the vernacular of science fiction. This concept came from a science fiction author, but also a computer science professor who said, oh, I'm looking at this plot. At some point, what do we hit? We cross that axis. Bam. We hit a singularity where we can't see beyond. What's going to happen in the future? Makes it really difficult for us to be able to make that prediction. And this goes back again to how our human intellect has gradually evolved over time, right? Over eons. But now computers and the ability of computers to rapidly change now happens in the span of decades, years, months is where we're at, right? Guess what? You were on GPT-3, now you're on GPT-4. Oh, not 4, 4 not, 5, right? And oh, guess what? 5 decided to upgrade itself to GPT-X, okay? And it's decided that all other GPTs and other computer programs are irrelevant now as part of that. This is what Werner Vinge said. We're at the point of accelerating the evolution of intelligence itself. The evolution of human intelligence took millions of years. We'll devise an equivalent advance in a fraction of time. It makes realistic extrapolations to an interstellar future impossible. What's our future going to look like? So as part of that, so we have a few minutes left. We'll do this quick demo here, right, and see how well our robot companion actually behaves. because this will be an example of what we'll see in the coming years as part of this. That's only if the person can get the case open, right? Because otherwise, the robot wins. Okay, helps if I don't change the code on it. All right, so this is our robot dog PD, and so it's a good example of what's available essentially commercially right now. And the main thing I want you to keep in mind, this is just a robot, because this goes back to our discussion on Tuesday in terms of how do we start to marry these things between the actual robot itself that's essentially doing the tasks for us, working with us in a way, but now taking in all that extra information that we have, that we're providing with it. So imagine we get to the point now, right, where we're essentially marrying this with our online generative AI capabilities that we start to see with something like ChatGPT, where we can now start to communicate with it. It takes a, voice to text, takes that information in, and starts to essentially be able to act on it in a way now that really starts to serve as that capability to do this. That it's not just our partner, right? It has the capability now to start to interact with the external world with us, essentially do tasks for us. Hey, can you go and pick up some medicine for me? I'm feeling sick, right? Have that delivered essentially by a drone, for example, okay, as part of that process. Okay. Now what you'll notice here, again, this is essentially the process now of working through the hard part, okay? The ChatGPT piece is easy. Why? It doesn't have to interact with the real world, okay? As far as being able to do the process of say, oh, what I want to do now is essentially be able to do the hard things such as dance, right? It can dance better than I can already. Much more graceful. And again, just like those examples that we had from the Boston Dynamics videos, to be able to essentially do things that humans cannot. Where now, it can't just beat you at chess, it can also beat you in boxing or combat or gymnastics, right? And taking that essential extension to say, yes, I'm happy class and the semester is over. All right. So with that, what we'll do is have him roll over and get back up. And again, regardless of what I do to it, and however mean I am to our robot creature, we always have to remember that they never forget. So think about how you're treating your robot companion in the future. Okay?